The appearance of what is believed to be China's next-generation stealth aircraft, potentially designated the J-36, is drawing significant international attention, not just for its visual characteristics but for what it represents in the broader context of global airpower competition. From a United States vantage point, this development is neither unexpected nor necessarily threatening in the near term, but it is a clear signal that China is seeking to erode the technological and strategic edge that the U.S. has maintained for decades in the realm of advanced air combat capabilities. The visual similarities between this aircraft and American designs are striking and deliberate. The tailless configuration, with its blended wing body and low observable contours, reflects a design philosophy the U.S. pioneered with aircraft like the B-2 Spirit and refined in the F-22 Raptor and F-35 Lightning II. This design approach minimizes radar cross-section and maximizes survivability in high-threat environments. China's adoption of these shapes suggests that it recognizes the effectiveness of the American stealth doctrine and is attempting to replicate it. However, there is a profound difference between shaping for stealth and achieving full-spectrum low observability, which includes radar-absorbing materials, internal heat and sound suppression, signature management from all angles, and electromagnetic discipline, all areas in which the United States has decades of experience and technological investment. The side-by-side cockpit configuration seen on this Chinese aircraft raises many questions. In modern Western stealth aircraft, tandem seating is the norm because it reduces frontal radar signature and is more aerodynamically efficient. A side-by-side layout typically introduces a larger cross-sectional area and could be more visible to radar. The choice of this configuration may indicate that this aircraft is not intended to function as a frontline air superiority fighter in the traditional sense but rather as a command and control platform, an electronic warfare aircraft, or potentially as a manned mothership in a manned-unmanned teaming concept. This would place it in a category similar to certain roles envisioned in the U.S. NGAD Next Generation Air Dominance architecture, which includes a mix of piloted aircraft and autonomous drones functioning together in a coordinated network. This detail matters because it suggests China is evolving its air combat doctrine to match emerging American concepts, where dominance is no longer measured only by platform versus platform comparisons, but by the ability to orchestrate entire systems of systems in highly contested environments. The United States has already shifted toward this model, where air superiority is maintained not only through stealth, speed, and firepower, but through real-time data fusion, artificial intelligence, distributed sensors, and multi-domain coordination across air, space, cyber, and the electromagnetic spectrum. But this type of capability does not develop overnight. The United States has invested over 40 years of continuous research, development, operational testing, and combat deployment to reach its current level of proficiency in stealth warfare. Programs such as the B-2, F-117, F-22, and F-35 have not only brought revolutionary capabilities to the U.S. Air Force but have also taught invaluable lessons about maintenance, logistics, sensor fusion, pilot workload, survivability, and joint force integration. These programs have matured through real-world conflict, from the Gulf War to modern operations in the Middle East, providing operational data that China simply does not possess. China's challenge is not just to build a stealth aircraft, but to field one that can operate seamlessly as part of a combat system. That means integrating it into an air command structure, securing the data it transmits and receives, ensuring it can function in a contested electromagnetic environment, and developing pilots and mission crews capable of exploiting its capabilities under pressure. The United States has developed and refined such a framework through countless exercises, war games, and live operations with allies around the world. This collective experience cannot be reverse-engineered from a photograph or a wind tunnel test. It is earned over decades of effort, and that is something China still lacks. Additionally, even if this aircraft reaches operational status, it must be viewed in the broader context of global power projection and force structure. The U.S. military is not just a collection of advanced platforms, it is a globally deployable, highly networked, alliance-backed force that can sustain high-tempo operations far from home bases. Stealth aircraft like the F-22 and F-35 are already integrated into joint and allied air operations across Europe, the Indo-Pacific, and the Middle East. These aircraft do not operate alone, they are supported by an ecosystem of airborne early warning systems, tankers, satellites, cyber defense, and logistics hubs that make sustained operations possible. The Chinese military, while modernizing rapidly, does not yet possess the global infrastructure or alliance system to project power at similar scale or duration. The United States is also not standing still. While China is unveiling its attempt at a fifth or sixth generation aircraft, the US is already advancing beyond with programs like NGAD, which are focused not only on stealth but on next-generation propulsion, artificial intelligence, autonomous teaming, cognitive electronic warfare, and advanced materials. The NGAD program is reportedly well into prototype testing, and its development includes lessons learned from every previous stealth platform. Moreover, these aircraft will be designed not just as isolated fighters, but as part of a larger ecosystem, including autonomous drones referred to as collaborative combat aircraft, highly secure battlefield networks, and adaptable mission configurations that allow rapid response to emerging threats. In essence, what this Chinese aircraft represents is not a sudden leap ahead, but an acknowledgement of American airpower leadership. The aircraft seems to be designed in response to what the US has already achieved and is continuing to evolve. This mirrors a familiar pattern in military development, where rival powers seek to close the gap with the leading innovator. The Soviet Union once tried to replicate the F-117 and B-2. China has already produced aircraft similar in appearance to the F-22, the J-20, and is now attempting to match American sixth-generation concepts. But history has shown that catching up in appearance does not equal parity in performance. The US response to this development should be measured, informed, and forward-looking. Continued investment in cutting-edge technologies, operational readiness, joint force training, and alliance cooperation will ensure that American airpower remains unmatched. The unveiling of the J-36, rather than signaling an erosion of US dominance, confirms that the rest of the world still views American innovation as the benchmark. That benchmark continues to evolve, and as long as the US remains committed to maintaining its edge across all domains, no single prototype or new airframe will be enough to tip the strategic balance. This aircraft is part of a larger game of technological adaptation, but the United States is still setting the pace.